Hi everyone, and welcome to the following of the msWallet.sol smart contract or multi-signature wallet. So we are here and we need to write the constructor. So constructor, and it will get the array of the addresses. So address square bracket memory owners. So at the time you want to enter the specifications of the contract before the deployment, you need to enter the addresses of the owners, which is an array, and also you enter 256 required signatures. So you will enter the number of required signatures at the beginning. So for example, if there are 3 addresses, then you can enter 2 for the required signatures. It's totally up to you what you can what you will enter. So now let's open the brackets, and so at first it will require that underline owners.length be greater than 0. So the array of the owners should be greater than 0, otherwise the user will see this message owners required. Owners required. There's also another requirement, which is the required signatures would also need to be greater than 0, and the required signatures should be smaller than the length of the array of the owners. So the for example, if you have 3 owners, then the signatures could be 3, 2, or 1, and it shouldn't also be 0, right? So from 1 to 3, the number of signatures should be in that range. So it will require that the required signatures be greater than 0, and here we should add and here, and the required signatures should also be smaller, equal than the owner's length. Owners.length. There we go, and otherwise it will show to the user invalid required signatures, invalid required signatures, or invalid number of required signatures. So next we will write a for loop here for iterating through the owner's length. So iterating through the owner's array. So we will write a for loop here. You enter 256, I equals to 0. So on the line owners dot length. So it will start from 0 up to the owner's length, and I++. So I++. So now let's open a bracket, and here, first of all, address owner equals address owner equals underline owners I, and in the next line, so in the next line we'll require that the owner not be the address 0. So require that the owner not be the address 0. otherwise invalid owner address, invalid owner address. And also it will require that the owner, the array of the owner inside of the array, actually the address not be the owner. So require that it will not be the, so is owner duplicate owner address, so the address shouldn't be repetitive. So duplicate owner address, duplicate owner address. So notice that here, if you enter a repetitive address, then the address will be one of the owners. So it will notice by this code whether the new owner has been recorded in the array of the owners or not. So after these two requirements are met, then we will push the owner to the owners array. So owners dot push owner, and then is owner of the owner will equal to true. So that's it. So the required signatures, that's it for a for loop, and the required signatures will equal to the underline required signatures. Okay, that's it for the constructor. Right now we'll write the function here, which is deposit. Deposit, it will get nothing, and it is public payable. There we go, and emit deposit, msg.sender instead of it, the first property, and msg.value, which is the balance of the message sender. There we go. And now the next function is the create transaction. Create transaction. So we'll get the address, the array of the addresses of the signers. So memory underline signers. The next thing is uint 256, the array of the amounts. So uint 256 array and memory underline amounts, and also the address of the recipient. So public only owner, so only owner is the modifier that we defined for some of our functions, so it will not need another requirement. So public only owner, and now we can open the brackets here. So we've got one requirement here. We can also make this a bit better. So public, also let's do it for this one, and write it in the short form so that it's better seen. There we go. Okay, and here we are instead of the function. So the first thing we need to write is the requirements of it. So it requires that the signer's length be greater than 0. Signers dot length be greater than 0. Otherwise, signers required. Signers required. And there is another requirement, require that the amounts that length be greater than 0. The amounts that length be greater than 0. Otherwise, amounts required. And by the way, let's write it in a more correct way. There we go. So now after these two requirements, there's another one. So it will require that the signer's length be equal to the amounts that length. So the signers underline signers that's length. So for these two we also have underline, right? So underline and underline be equal to the amounts that length. And it's obvious because for the number of signers we need the number of amounts. Otherwise it won't work for us. Invalid input length. Otherwise invalid input length. So now we'll declare the uint256 transaction ID, uint256 transaction ID, which is equals to uint256. Open the brackets, open the parentheses, and keycheck 256. Open the parentheses, abi dot encode packed, encode packed, encode packed, block dot number, block dot number. So also timestamp. And recipient. So this is how we encode the transaction ID. This is a transaction ID is a kind of a string that we will write by writing the decode, actually encoding it. So it will be uint256 and a number, so that, and then it will be encoded with keycheck 256. And it will get the ABI of the smart contract and encode it, and get the block with the block number, timestamp, and the recipient address. So it's not very important if you don't understand it, because this is just an encoding for transaction ID. Now let's write our for loop. So for uint256 I equals 0, and then we'll have semicolon I smaller than underline amounts dot length, semicolon, and I plus plus. So this is semicolon, not colon, so make sure you enter them correctly. So there we go. Here we are inside of the for loop, and address signer equals address signer equals underlying signers I, and also it will require that is owner signer, the signer to be the owner. So require that is owner signer be the owner, signer also be the owner of the smart contract. So otherwise we'll show to the user invalid signer. There's another requirement. We will require that to be the transaction ID of the signer not be approved. So is approved, transaction ID of the signer not to be approved, otherwise duplicate signer. This is for the place where we want to enter the actually create a transaction and enter the signers. So if we write them repetitively, then this is the way it will let us know that it is repetitive and we should enter another address. So the two addresses or three addresses, or how many number of addresses for being the signers, then that number of addresses shouldn't be repetitive. They should be unique. So right now we'll set the is approved for the transaction ID signer, transaction ID of the signer equals to true, meaning that we're approving this signer. And there is another for loop that we need to write. So let's close this one, actually get out of this one and write another for loop. For uint 256 I equals to 0, uint 256 I equals to 0, semicolon, and I less than the amounts.length, I less than the underline amounts.length, I plus plus. So open the brackets, and here this is a short for loop. Transaction amounts of the transaction ID be incremented, but be added with the amounts I. So transaction amounts of the transaction ID plus equal with the underlying amounts I. And that's it. So we'll emit the transaction created. Up to now the transaction is created but not executed. Transaction created, and so transaction ID, get the transaction ID, message sender, msg.sender, and the signers the underlying amount and underlying recipient. There we go. So limit the transaction here. There we go, and that's it for this function right here. So we'll continue with the rest of the functions in the next part. So until the next video, goodbye.